Hello, everyone. Welcome to our YouTube live session. We'll get started in about a minute. We just see a few people still joining in. Okay, why don't we get started? Thank you, everyone, for joining. We'll just do some quick intros before we dig into our session. My name is Charlie Ogden, and I'm a product manager at Autodesk. I'm focused on grading and drainage features in our infrastructure features or products. Val?
Hello, everyone. I'm excited to be in this YouTube live session today. My name is Valentin Koch. I'm a principal research engineer at Autodesk in the infrastructure group.
And John?
And my name's John Sayer. I'm a technical marketing manager here at Autodesk. And I'm glad to be here today to help answer some of the questions in the chat that you guys have got.
Great. All right, and you may see today's session is part 2 of our 6 YouTube Live Ask Me Anything sessions. We put these together in order to help you learn more about grading optimization for Civil 3D. And under this YouTube video in the description, you'll find the links to the other sessions, including the last one that we did in case you missed that. So make sure you click on the reminders to watch more in the future, and also watch any that you've missed as we go. So feel free to tell us where you're joining from and ask any questions you have in the chat box. We'd love to hear from you. And as John said, he's going to be helping out and answering questions in there as we go. And so if there are any questions left over at the end, we'll leave some time afterwards, after the presentation, to have a Q&A session. So with that, I think we'll get started here. Share my screen. So we're going to start with the model we ended up with last time in the first session. Basically there we graded the building pad, the parking area, the roadway here coming in, and we talked about the grading limit. So today we're going to take a little further. We have a pathway between the parking lot and the building. We also have some curbs along the road and a few other things to kind of control some elevations around the building. So with that.
Yeah, let's start with the building pad then. So last time we just selected that building pad and made it a building pad and nothing else. This time we're going to look at some more properties of that building pad. So if you look at the property panel here, the first thing you can see is an elevation slider. If we turn that one on, that's actually straightforward. I mean, what you can enter here is the minimum and the maximum elevation of your building pad. That's straightforward. So if you, for example, you have requirements that the height of your building can't be higher than something because of airports close by or the view of some other properties behind it, you just enter this range in here. You can also put the fixed elevation value when you turn the slider there up and just enter one fixed elevation. Now, in general, in the optimization, it's always good to let the solver give him some freedom to move. So if you have a range, I would go with a range. If you don't need elevation bounds, don't put them. Let the solver move this building up and down, because that way it's easier for the solver to balance volumes or to satisfy other constraints. So in this case, we don't need anything elevation wise, and so we turn that off. Now the second slider that you have down there is level grading with pad. So what's that? And I think to show what's this, it's better to go right away into grading optimization. So we're gonna start it up. And what we're gonna do is, to show better what this does, we're gonna go to the grading limit. Remember, that's the zone that we put right in the beginning. And we set the drain slope to 0 there. Just again, what we're gonna do, what this means is we relax the problem, we give the solver more room. And now we go to the building pad and turn that level grading with pad off. And then we just let it run. And we look at it, and as we look at the building, Charlie can maybe zoom in a little bit towards that building pad, sorry. You can see how it gets kind of cut into the terrain here, and you can see like these little walls appearing along the building pad in the back, and in the front it looks like cut in like with a cookie cutter. We call these things reveals. So when you have level grading with pad off, that's what the solver does. It just does the easiest way to put this building pad flat. It's cutting right along into the terrain. Oftentimes you don't want that, because yeah, oftentimes it's easier if you can just grade up right to the building. And so we can show again when you turn that slider on there, level grading with pad, and we rerun. And you can see that these reveals are going to disappear. Now, one thing you need to realize is that level grading with pad is actually not a constraint. So as you can see in the corner in the front left there, you can see there's still a little corner where you have a little bit reveal showing. And that has to do with the slope constraints there. So if the solver cannot, it will not level grading with pad. So that's just a nice to have. And you can see it can do it almost everywhere here, but sometimes it can't. Now, to show you this even better, we go back to the grading limit and we turn the drain slope on again.
Stop. Good.
Yeah, stop that. Put the drain slope to 1% maybe.
Yep.
And here we can see again, now because now we have more constraints, right? We have drain constraints. So it's harder for the solver. So now it doesn't care that much about this level grading with pad anymore, because as I said, it's an objective. You can see in the back where he shows Charlie, you can see it's filling up a little bit there, because remember, we have a drain slope that goes to the back there to that road. And in order to get to this 1%, it's filling up in front of the building. So if we want to get rid of that, Charlie, can you show a way how to constrain that actually, these reveals?
Yeah, and we'll go back to Civil 3D. So like Val said, this is more of an objective. It tries to meet it, but we can add what we've called a reveal. It'll act more as a constraint and just be a little more forced to try to meet that. And we can add, so the idea of a reveal is basically how much of this foundation is revealed or showing. So it might be more, you might run into it in a case where if you need a loading dock and you need 3.5 feet or 4 feet or whatever of foundation wall showing, or a drop from the floor to the ground around it. So that would be revealing part of that foundation. So that could be a place you'd use it. But in the case we're talking about here, it's maybe more you just want a 0 reveal and you want to try to help it force to tie into the ground. But it could be a step. So any certain distance or drop you want from the floor to the ground around it. So let me go back to Civil 3D where we can add these. And there's a couple ways to add them. One is through the tools like we used last time. You'll see reveal right under building pad. And then I select the building. And then it's just prompting me to draw where I want this reveal. And I'm just going to draw it basically where we saw that kind of raising up above the ground. So just kind of force a 0 reveal here. I'm going to use a fixed elevation of 0. And I'll just name this so I know what's what, but that's the front of the building. And in this design here, you might also want one at the walkway. So I'm gonna add another reveal there. Another way to do this though is to select the building and right click. And then you'll see reveal segment here and you can add on, or you can go and edit the one that I just made. So I'm gonna add, and I'm just gonna snap where this walkway connects. And I'll also make this one 0. And that's the entrance. And then we wanted to show a loading dock, but we really don't have a lot of room on this site. It's pretty flat. And it's not obviously lined up with the parking lot or anything. So instead, we're going to create a similar idea, but maybe we just want a bit of a reveal here along this wall so that we can have some maybe windows if there was a basement underneath or something. So what I'm going to do is add another reveal just along this back wall. And for this one, we're just saying this is for some windows. This one, I won't have a fixed value. Maybe I want a range. So you can do that too. I'm just going to have a slight range here. For a loading dock, maybe you want a little bit, bigger, 3.5 to 4 or something. So that you do the same way if you had a little flexibility in that. You could also, which I've kept the start and the end the same, but if you wanted to, you could always make the start of this, the reveal at the start and the reveal at the end, different values as well. But I'll leave those the same, and we'll just go back to creating optimization. See what this does. Run this. And you can see them, if I can zoom in here, you can see them shown in this window as well, the little arrows running around there. You might see the building kind of lift, or the ground around the building even lift up a little at first. But and we pointed out the convergence graph last time, as that goes along and starts to solve things, you should start to see them come closer together. And just exaggerate this a little bit.
Yeah, sometimes this convergence plot goes a little up and down, wiggly, but still in a downward trend. And that's when you see sometimes the building pad comes up and goes down, and it wiggles the things into place.
So you can see it's starting to make a deeper reveal here. It's trying to keep it flush with the entrance there, and it looks like it's doing the same in the back, or that's actually the front, I guess. Now, something else I didn't really show either, but maybe this building pad, if that was a slab that's actually in a basement or a cellar, you might actually want that to get lowered into the ground to come for earthwork and everything, but still have the ground up above higher. You could put in a negative reveal in that case. So negative amount of foundation showing because it's all on the ground. All right, so that's kind of how we can control the elevations a little bit better around the building.
Okay. Let's go back to Civil 3D and look at some other nice side features we have. And that's curbs. So what are curbs? Well, everybody know what knows what curbs are, but we have two types of curbs here in the grading optimization. One is the open curb, the other is the closed one. Closed ones are kind of curb islands. So if, for example, here you have a polygon, you select this is a closed polygon, you assign a curb to it. And here is one thing you need to, there are a few things you need to be aware of. So you can change the height and the width of the curb. We can go, for example, 1/2 foot there, 1/2 foot wide. And when you look at this blue line, there is a light blue shaded line, and that shows you the top of the curb. So in this case, we want this actually, it's the wrong way. So there is this slider reverse curb where you can change that. So you want to make sure that, you know, in this curb island that the top is inside. So the kind of the lighter blue area is inside and the dark blue is the bottom. So in this case, we can leave it now. And same thing for an open curb. So we can select some polylines that are not closed, like this one, do the same thing. And here again, we want to reverse it because the light blue is the top. Yeah, that looks right to me. And we can also go all around the building there. Again, this is right. The light blue is in the inside. I think this is all the, oh, and one curb there. And it's already right. So nothing to do there. Now, Charlie, I didn't check, are the width and heights all, oh yeah, they're all good.
Yeah, they're all. Yeah,
So,
by default, you might want to change these. It looks like I already did. So if you right click on your curb, go to properties, you can change these to 0.5. I think by default they're 0.2, which is more of a metric version value.
then you don't have to go and change it all the time. Yeah. So let's run that and show the audience how nice these curbs look like. And for that, I think we're going to change again the contour interval in our.
Yeah, I'll exaggerate a little. We can change the contour interval.
There you go. And I can see already at the beginning, they start to pop up.
What happened with my island? Oh, I lost it.
You lost the island? Oh, well. That makes it easier to drive in and out, so no problem. So if you show the convergence plot again, it's still working hard to get this into place. So if you get down to 1, maybe things are really nice, but we can already see these curves showing up quite nice. And the grading on top, still the same thing. Like, so it takes, the curbs don't affect your slope constraints on the zones. So it's just raising everything by that height you did. But other than that, it's still the same thing. It's looking nice.
All right. All right, so we can go back to Civil 3D. We can take a look at some other things, like we had a sidewalk in here from the parking lot to the building. So let me go back.
You want to quickly assign the curb?
Oh, yeah.
Just that it looks nicer after. There.
I think this one went away too for some reason. There we go. Yeah, so we'll see that next time. But yeah, so we have this sidewalk drawn in from the parking area to the building. And let me turn on a layer for that. I just used bpoly command just to create a closed area because our zones are closed. I also have some geometry for some ramps. So let's look at these. So this one here is just a sidewalk, kind of wraps around, and goes out into the road. So we'll add this as a zone. And we do already have some zones. So remember from last time, it is important to name these so we know what's what once we start looking at things and need to change it. So let me put in some slopes here. Actually, for this, I'll leave this 0 just to give a little flexibility. If you're concerned about the minimum slope, you can put that in, but I think I'll start with it at 0 and we'll see how that goes. I think there's going to be plenty of slope there for this.
Like I said, always give the solver flexibility, relax things as much as possible. It's easier.
And then we have a couple accessible parking spots here. And we maybe want those a little flatter. I think our parking lot was 5% max, and maybe we want these at 2%. So let me just quickly draw in a new zone. And this, I'm just drawing a closed polyline. Close it. Right, that's all we really need. And then I can select that as a zone. And I'll call this accessible parking. And let's make this flatter. So I'll do 2 and 0. 2% max here.
It's 0 is good too.
0.
It will just, you can put 0 because it will just align itself with the overall drainage pattern around it. So you can always tighten constraints, but it's good to have them relaxed. Did you have another zone that you want to?
Yeah, so we might want a couple ramps here, ramp from these spaces because we do have a curb in between. This is in between a curb, so maybe we want to ramp it up to the sidewalk. And I know this gets steep, so I probably want another ramp to get from that elevation up to the building. So with these two, I'm going to add them as zones as well. And I'm going to use, I have 2 selected, so I'm going to choose custom slope constraints again. These can be up to 8%. So I'll just changing the max instead of the 5% for the pathway to be 8%. So it's steeper.
Maybe you want to name them too.
Yeah, they are grabbing the name of my layer by default if I don't name them. So I can tell they're ramps because I put them on the ramp layer. I can also pick them and oops, I should have numbered them. So ramp 2, 1, sure. So a couple ramps. Now this ramp is over the sidewalk and this parking, our accessible parking is over our parking lot area.
Well, here's the question. Are they really over or under it? And that's where zone priorities come into play. And this is something that you can change, but only in the grading optimization application. Priorities are basically how you arrange zones. So this is a good picture that Charlie shows you. Can you zoom a little bit out to show on the side the no, doesn't show the, there's the these arrows, where they're coming from is from your it's the tree view of your grading elements. And so we have a few zones there and they are in a certain order. So the green arrow goes to a zone that's at the top, and then the blue arrow that goes to a zone that is ordered in the middle, and then the yellow goes to a zone that is at the bottom. So it really matters in which order they are in the tree view. So, and if you have them ordered this way, you can see on the right side, this is how the solver is going to see this, like from a bird's eye view. So they're like layers. So the top one overrides the ones below. So the green one you can see overrides the blue and the yellow one. So you're going to have an area, might be grass, for example, where you have a max slope of 17%. So it overrides your grading limit 33 and your blue one 5. And then the blue one, that might be a parking area. And that overwrites, yeah, now we can see it.
I
That
have the wrong
meaning-
image, sorry.
You had the wrong image. So the blue one you can see overrides the grading limit, but gets overwritten by the green one. And so here in the tree view, we call them zone A, zone B grading limit. One thing that you need to realize is, so you will have to reorder the priority in this tree view, but you cannot do that in Civil 3D. So this only works, drag and drop of these zones only works in Geo. We're going to show that right away, actually.
So first of all, the tree views here that I was discussing, but I can't drag and drop on this, as he said. So I'll launch optimization.
It's the same tree view.
Here, same tree view, same objects here. The newer ones get placed at the bottom, so you can see the ramps that I made last are here at the bottom. So I'll bring the ramps up, and I'll bring the accessible parking up. The others don't really matter since they're not actually overlapping anything else. Of
Side by
course,
side, yeah.
you could rearrange them if you wanted to, but for other purposes, just keeping track of them. But
So when you're solving something and slopes don't work the way you expect them to work, then make sure that your zone priority is right, because that's often the #1 mistake, that people forget to order them. And then they, why is it so steep here? My parking lot is way too steep. Well, maybe it's underneath your grading limit, or not the grading limit because that's one separate, but underneath something else. So make sure you check this zone priority before you run.
and here we'll run it. And you can see where the sidewalk is. I'm going to turn on the violation view. In here, you can hover around. And this might be a good clue as well. If the slopes aren't doing what you expect, you can see here what it's expecting and what it actually is. So where it says slope max 2%, that's what it's expecting as the maximum slope, but you can see in red, it's currently, as it's still solving, at 2.9%.
And sometimes you just have to let it solve a little bit. Again, the convergence plot tells you kind of how far it's on solving. If it's going down, just let it work.
But outside this accessible parking area and the rest of the parking spot or parking lot, you can see 5%. So if you don't see that, then like Val said, that might be an issue with the priority here.
Or it might be just that your setup is just causing problems. That's often the case too, that people enter things that cannot be done.
Hey, Val.
Yes, John?
Hey, I was noticing the slopes that were set on the sidewalk. Are those, is there a way to control cross slopes of the sidewalk?
Cross slopes, not right now, no. In the current version, there are no cross slopes, but if you want to know if there will be cross slopes soon, well, if you want to answer to that, you can join the Infrastructure Futures, the beta program. You have to create an account. You know this one, John, right? You could maybe post a link to that one.
Yes, I can do that.
And in there, you can download like beta versions as new features, and you can ask questions that we can tell you what's
Coming.
What's planned, what's maybe coming. But the current version does not allow for cross slopes.
I would definitely encourage everyone on the call or everyone on the live session here to join the Futures site, because it is a great preview as to what's coming, and you get to submit your comments and talk about those things. So I'd highly recommend that you join the feedback site.
Right. So one other thing we wanted to talk about was another way to control elevation differences between objects. For example, maybe if we have this building here and we want it maybe to try and get it to be a certain elevation above another area. So Val talked in the beginning about setting the elevations on the building, but maybe that doesn't matter as much as the difference between the building and maybe the parking, or the building and the road out here, or the building and another building. Maybe you want to have certain elevation differences between different objects. So to do that, we can use this elevation offset tool, and maybe between the building and the road, maybe your customer wants the building to be a couple feet higher than the road, just for visibility. Or maybe that for designing utilities, you need to get it a certain elevation higher just so you can get things to flow by gravity. Whatever the reason is, we can go back here to Civil 3D and show how to use the elevation offset tool. And for this, I'm really just going to draw in a polyline, and I'm just going to draw it between, say, somewhere inside the building. It doesn't really matter where, because the whole building's supposed to be at the same elevation. So I'll just pick somewhere in the middle and just go out. Maybe you want it above the road. So I'm just going to pick near the road. One thing I'll just mention right now, you don't want this to go outside our grading limit, which I think is this red line. If it goes outside the grading limit, what's that, Val?
Yeah, because it digs a hole otherwise outside there.
Yeah.
If this is going to be fixed, again, that would be a question for the beta forum.
So for now, I'm just carefully going to keep it inside the grading limit. So we can set what the elevation should be above that point. So if I add with my tools here, find elevation offset, and I'm just going to select this, again, just a polyline I drew. And I'm just going to say height over road. I know what it is. This could be a fixed elevation difference. I'm going to untoggle that so I can put in a range, and I'll just leave it 1 to 2 feet. So I want it higher than the road. Try to get it higher than the road here. Now, what this is doing is it's just setting this elevation offset between the start of the line and the end of the line. It's not doing anything in between. It's not keeping a consistent slope or anything between those. It's just fixing between one point and another point. So it's really the elevation difference between the start and end points. So I'm going to go back to grading optimization, and we'll see how this works. And maximize and run it.
The violation view on again.
Yeah, a couple things. Turning on convergence graph and turn on the violation view. Just exaggerate this a little too. See, it's still doing that reveal.
But you can see it's really in the beginning of solving everything on that convergence plot. So it's
Still coming down.
you have to let it crunch these numbers.
And there's still a lot of red here too.
Now it's going to bring the building slowly up there, is it?
It's going to try to, right? Let's see. Oh, I have to move this and then we can see. As I hover down the lower left here, you can see the elevation value. So if I hover over the building, you can see it's around 86, 7. Out here at the sidewalk, it's 86.3, so not quite a foot.
And it's trying to put these reveals into place that you had there too, which means it has to bring the building up a little bit. But
So we could let this run longer, but I know it's not quite going to achieve the 1 foot. And so we thought we'd kind of point this out. Why do you?
yeah, first Charlie and I we were thinking, yeah, maybe we should put this elevation offset somewhere else so that it looks nice. But then he told me, well, this is actually a good way to teach people that sometimes things just don't work the way you plan. And here, the reason is, I mean, if you look at this elevation offset, so it's going to pull this, it has to pull this building up so that it can get to the 1 to 2 feet. And in order to do that, yeah, it pulls it up, but at the back of the building, yes, exactly there, you can see there it's red. And the reason is we have a maximum slope there, a constraint. We have a drain slope, which is the lighter red one. And these, it cannot pull the building back higher. It's going to violate these maximum slopes there. And that's what's happening here. So it's struggling between, it's over constrained. So there is no solution to this problem. And this is something that sometimes it requires users, you know, you look at a problem like this and you think, why isn't it working? Well, it's not because the solver is wrong. It's just because what we tell the solver to do is not possible. We cannot have this elevation difference of 1 foot there to the road and at the same time have our maximum slopes in the back the way we want. It's just not possible. So this way, grading optimization acts as kind of an analysis tool that tells us, hey, what you're planning is actually not possible.
Yeah, it wants to bring in the front, wants to bring the building up higher, but in the back, it's trying to pull the building down to meet those constraints.
We had many of these things too, John, right? Where we just thought we could design it this way, but it didn't do it because it's not possible.
Yes, we have.
So I think, you know, we could let this run. I think it's starting to level out. Actually, it probably dips down a little bit more and then levels out. But for sake of time, let me just stop this and we'll just bring this back. So we did this last time too, but just sending now the result back instead of just closing. Up till now today, I've just been closing the window just to go back to Civil 3D and make changes. But this time I actually want to bring the results back. So, so again, choose a surface, the feature lines to bring back. We do already have the surface from last time, so I called it Geo. So you could create a new one or just choose to update this surface that's coming back. Same with the feature lines. I think I put them in the none site last time. Maybe this time I'll just put these in a Geo site. So create a new site for the feature lines here. And then let those come back into our Civil 3D drawing. So update the Geo surface, and that should create a new site for us as well. See, there's no sites right now. There's the site. Get this out of the way. And I think the surface is off. So let me just change this to 1 and 5.
Let's show us what we did.
Let's see. Oh, there it is. All right, so yeah, you can see the contours from in the parking in the road as well. And if I look at this in the object viewer, oops,
There's top, yeah.
you can see the curbs get defined. The elevation drop there on that side of the building.
This is all without placing manual feature lines. It's neat.
All right.
That's okay.
Yeah,
We apologize. This is Charlie's first day with the object viewer.
I think I changed my object
Inform,
viewer
I think.
rotation setting because it's like, all right, anyway, so yeah, that's basically what we wanted to show today. So yeah, John, are there any, want to take it away with some of the questions in the Q&A, if there are any?
There were a couple questions. One of them was back when you were talking about the building pad and reveals and things of that nature, and you went into the optimizer and was looking at the violation views. The question was, why does the solver create triangulation and slopes inside the building pad area? And they commented a little further. This seems like wasted processing effort, seeing as how the pad should be assumed to be flat.
Yeah, the reason has to do with the volumes. The solver needs triangles to, when it balances, it needs triangles to compute the volumes and balance them. So it's not possible without triangles to balance.
Okay.
It's probably adding pretty minimal to the processing for that relative to the rest of it. I mean, because they're fairly large triangles in there.
Yeah, I was going to say the triangles inside the building would be pretty large. So not like some of the triangles we've run into, Val, on some other more complicated sites.
That's right. If you could see, they were actually red on the building pad, but the violation was saying the max slope, which should be 0, was violated. But if we would look at these, it would be very minimal violations. I mean, we're talking about violations that are not even gradable by a bulldozer. So.
All right. There was another question, and I think you showed it whenever you brought the surface back in. It kind of answered the question, but can you? Well, the question was: is after I do optimization, is it possible to extract feature lines from the zones? So, can you tell us? There is an option inside whenever you're inside Civil 3D. Whenever you bring the surface back in, it gives you the option to actually bring in the feature lines. So what feature lines is it bringing in? Can you explain that?
Yeah, so it's bringing in basically a version of the objects we started with. So we started with a polyline for the curbs, polyline for the building outline, polyline for the parking. In my case, they were all polylines. They could have been feature lines or other objects. But what it's doing is bringing back a feature line for each of those. And the feature line, instead of just being a 2D element that we started with, it's now brought back the feature line with the optimized elevations on it. And I believe we try to do a good job here of naming them. So it's basically the same name, but a feature line version of that. And you can see also in the case of a curb, there's a top and a bottom because it does do a slight offset for the curb. So you get top and bottom of curb, even though we just started with one polyline for the run of the curb.
Same as building pad.
Yeah. Yeah, with the building, there's a slight offset too that's to the inside that gets flat, and then along, the outer one is basically the ground elevation at the building. And
Okay.
same with ponds, but we can talk more about ponds, I think, in the next session, since we didn't create a pond here.
Okay. There was another question. Why is the surface built from a land XML versus the feature lines brought into the file?
It's just a way to bring back, I guess, the actual surface that we had in grading optimization. You could certainly come in here and just create a new surface. Just like the name, right? And then come to your collection of feature lines and just add those to a surface as a break line. And I'll just add it to that new surface I created. Geo. So yeah, we're not doing that automatically, but you can certainly do that to create a surface. That link is to. Just want to be able to grab this, so some other style. So yeah, I mean, you probably want to put a boundary on it too, but this is just quickly creating it from the feature lines that get returned. So you could certainly do that too.
If you don't like too many triangles, right?
Yeah, the returning it as the same surface is just a quick way to get a surface in there that you can then just do some analysis on or use it to compare for volumes or something. But certainly this would probably, what I just did would probably be the workflow to create your actual final surface, create a new one, bring the optimized feature lines into it, because now with this surface, you can add additional feature lines if you want. You could use it with some other grading. So you have some control over how this surface is getting created and make it more detailed.
All right. Well, that's all of the questions that we have. I did want to bring up, so Charlie and Val and I were talking about it. We've got 6 of these sessions planned, and we kind of were talking about the last session that we were going to have, which is in the future a little ways. But the topic of that session, we've kind of gone back and forth on it. What we kind of all came to an agreement on is maybe we have some of you guys, the folks that are watching the live show here, if maybe you guys submit or let us grade one of your sites. All right, maybe something that you're having a problem with, maybe something that is of a much larger scale than this little project here. By the way, we use a smaller data set like this just so that it makes things a little bit easier to understand instead of trying to set multiple zones on some, on a giant complex. Not to say that it can't be done, for sure, we've done it, but this a smaller data set like this just makes it easier to explain and makes it easier to consume. So that's kind of why we do it. But we talked about having you guys submit something to us. Now we would have to get something set up in an email, and we can talk about that in the next session. We'd have to set up an email address to allow you to send us the data, and not give out Charlie's email address today to everybody here on the call, to the world. we could do that for Val, but not Charlie.
I can type it. Yeah.
But we would like, I mean, you can, if that's a good idea for the last session, you're welcome to put that in the chat. If you've got an idea of a project you'd like to see how grading optimization would work on it, period, then say that you're interested, and we can kind of track that and maybe get a hold of you. So just wanted to throw that out there. There was another question here that I'm going to throw out to you guys. It says they don't see the benefit of grading optimization, nor most of the Civil 3D grading commands for a simple plot plat. It says it's like using a sledgehammer when you need a needle to sew. Do you guys have a response to that?
So simple plat meaning like a
I'm assuming
building
like
on a
this.
lot?
Like this data set here.
Yeah. Well, and we kind of talked about that at the beginning of the first session. Certainly if it's so simple that you can just do it with, you know exactly what the elevation of this building needs to be graded to the road in the parking lot. Definitely, you probably don't need grading optimization to do that. But the more you have, multiple buildings, multiple parking areas, roads through them. I showed an image of a different site last time that was definitely more complex with walkways between everything. It is more cases like that because we're really using grading optimization, not to automate grading, but to help you figure out what's the best grading solution to start with. So it's trying to optimize it.
Even figure out, is it possible, what you want to do, right? And then the other thing is balancing and minimizing volumes. We all know that's a very time consuming task. So, but yeah, just one pad, you can balance that very quickly by hand. You don't need Geo for that. But just this side, balancing it to the volumes we had last time, that takes already a lot of time, I would say. No, John?
Yes, it does. There was another question by the same person, but I think that they were saying it'd be great to see how fast you can grade a simple single family plot plan, holding the edge of pavement and see what can be done. And again, that's a great example. If you've got one of those project, or you've got a project that we could do that on for that session later on in the year, then let us know, and we can show you how, well, we can show you how it works. That's all we've got, guys.
All right.
Appreciate
Great.
all the
Well,
questions.
Yeah, thank you. Yeah, thanks again, everyone, for joining. Again, this YouTube session is going to be saved on our channel, so feel free to watch it again anytime. Share it with your coworkers. You can also, go back and watch the earlier one as well, so they all will get saved there. And if you're also, remember to set your reminders for the upcoming web sessions as well. Again, the links are down at the bottom underneath this session. You'll find links to all the future grading optimization YouTube live sessions, as well as the one we did earlier, and we'll put them up there as they're saved. So all the links are there. So thank you everyone again for your time. Thanks to the team for being online, John helping to answer questions, and have a great day, everyone, and we'll see you again in the next session. Thank you.
See you, everyone.
Guys.